I guess I'll go ahead and start with what I have just to keep things going. But kind of the key point here is that DNSSEC adds some challenges, adds a little bit of complexity to the DNS protocol, and in some ways can challenge the availability of DNS if not configured properly. So, of course, it is a security retrofit, and that's some of the challenge that one of the things that makes it challenging. And so the objectives in this are to first of all establish a model for analyzing availability in a DNSSEC deployment, and then look at different ways, some of the things that increase complexity in a DNSSEC deployment that may make it challenging, particularly challenging to maintain, and then talk about a couple ways to mitigate the effects of misconfiguration. Okay, so there are three kind of classes of DNSSEC misconfiguration. I've outlined them here, and I'll just kind of enumerate some of the ways. So first of all, regarding what I call zone class misconfigurations, and these I call them zone class because they're basically contained within the zone themselves. And within this category, regarding signatures, if the signatures are either missing, expired, or bogus, in other words, they don't match the record data that they cover, then of course they are not helpful, and that will cause a break in the chain of trust. Also, if the DNS keys are missing that are necessary to verify the signature, then this is problematic and will also result in a chain of trust. So again, these are in zone class misconfigurations. You might ask why the signatures might be missing, and there are a couple of possible reasons for this, which I'll go into a little bit more detail later. But missing signatures could be because either the zone, they're missing from the zone themselves for some reason, maybe the signer didn't include them properly, or it could be because the server, the authoritative server, is not DNSSEC compatible and isn't actually returning them. In either case, it's a bad situation. And likewise, there are cases where there are server incompatibilities for not recognizing the DNS key resource record type. So that's another item there. And then delegation class misconfigurations extend beyond the zone itself and basically refer to breaks in the chain because there are DS records in the parent that don't correspond to any, I should say there are no DS records in the parent that correspond to any DNS key resource record in the child, but there are DS records in the parent. That's problematic. Or in the case of an insecure delegation, it could be that the parent zone is not or one of the servers authoritative for the parent zone is not returning the NSEC resource records appropriate to make that insecure delegation. And those are particularly important for insecure delegations because the authoritative server has to prove to the resolver that there are no DS resource records so that it knows that it's an insecure delegation. And then trust anchor misconfiguration has to do with that's really between the resolver and the zone with which it's been configured. I'm not really going to spend much time on that in this particular presentation, though. Okay, so one of the interesting things about failure with regard to DNSSEC misconfiguration that it's really not cut and dry. It's not always a 0-1 type thing. And particularly in our early deployment, we would often see cases where, and part of this is because of the way we deployed things, but we would see cases where a valid chain existed, but in fact there were also invalid paths, or I should say there were problems with this, with a particular deployment in only some of the servers. And so in my particular example here, what I mean by that is let's say we have this zone bar.com where one of the servers is serving good data, one of them is serving data that is bogus, meaning, again, maybe there's a DNS key missing from the resource record set, or that particular server is not serving the resource record signatures as it should be. And then we have a third server here that's non-responsive. Well, if we consider only the responsive servers, because all servers should try and go to the next server if they don't get a response, however, that may not necessarily be the case if they get an invalid response, invalid meaning data-wise, then we consider those and we just take that fraction. That's what we would consider the failure potential for, failure potential for that particular zone. Okay, so looking at that, now this can be, I should mention that this can be problematic for a couple of different reasons. We have some pretty smart resolvers out there doing validation, and I know Bind and I believe Unbound as well will try other servers if it gets an invalid result from one of them, which is good, but there are certain cases where that may not help. One of those is if you, for example, are behind if your validating resolver is behind a non-validating cache, then you really are at the whim of what is in the upstream cache, if that makes sense. You can't really go to you can't try your next authoritative server because you're forced to what's used in that non-validating cache. Or that cache may be validating but isn't as smart as one of these other validators, for example. There may be also cases where, well, the other prime example is you may have some of your servers working and so everything seems fine, but now you lose your redundancy both in terms of failover and load balancing. So this can be problematic if your servers aren't doing well, if they aren't consistent, I should say. Okay, so we can take this notion of failure potential and just extend it to all the zones in the hierarchy, basically by, and what this essentially does, it says, okay, what's 1 minus probability that you're not getting, that you're not having any problems in any of your zones. And so using that model, this is kind of what we're doing for on each zone, which I'll show you in this analysis in just a moment. This is what we use to calculate this. Oh, these are really old slides, actually. Okay. So this is not, I had a more recent survey that actually covered about a 5-month period, and the results were slightly more interesting, and I had it broken down by error type. So I apologize for not having that, but so this was just a smaller polling period that I did over a 6-week period with about 1,500 zones that I considered production signed, and what I mean by that is that they had a chain or a would-be chain if it was broken, extending from that zone to either ISC's DLV service or the root zone after the signing of the root zone in July. And what we found was out of this subset of zones that we analyzed, we had about 194 misconfigurations that resulted in certain failure, meaning the failure potential was 1. Okay, and out of this, we had about 69% of those were zone class misconfigurations and delegation class misconfigurations. Again, this has to do with either something that, the delegation class misconfigurations have to do with a DS mismatch with the DNS keys in the child zone. Those accounted for about 31%. The misconfigurations that resulted in a failure potential of 1. And then this bottom number has some pertinence to something I'll talk about a little bit later, but this basically is if it had to do with some kind of problem with something above the zone itself. Okay, so it wasn't necessarily the fault of the zone, I should say. It's about 31% of those. Okay, so here's kind of a graph that shows the failure potential. This is an average for all the zones over the 6-week period that we analyzed them. And so the good thing was there was about 12% that had an average failure potential of 0. The bad news is that we had about 2% that never left the ground during this time that we had it, meaning they had a problem the entire time that they were under our watch during this polling period. So pretty interesting results. So the next thing we asked is what are some of the questions we might ask in terms of what makes things difficult for DNSSEC deployment? Well, if we look at it in terms of this failure potential we're looking at, the numbers that we came up with were calculated from two different perspectives, and one of those was the horizontal perspective, looking at the authoritative servers and the consistency among those servers. And then there was the ancestry of the zone, and so looking at kind of the vertical perspective. And so if we look at the complexity at those two different areas and see how we can simplify things, these are kind of the questions we were asking. So we call these hierarchical complexity and administrative complexity. And hierarchical reduction potential, we asked ourselves, okay, if the ancestry of a zone might reasonably be consolidated, meaning if you were to take your subdomain space of a delegated zone and then move it up into its parent zone, preserving the original namespace, but just consolidating the zones, what might that reduction be? So in our example here, taking from 4 to 3 is a reduction of 0.25. Okay, and then administrative complexity is really looking at the organizations that are hosting the servers authoritative for a particular zone. Okay, and now I don't mean to say in both of these examples that having a large ancestry is necessarily bad, or that having other people host your authoritative data is bad, but there are certainly some concerns with that. Only because you don't necessarily have control over what they're doing. And this means both in terms of what level of DNSSEC they're supporting on their servers. They may unilaterally make a change on their firewall, and now all of a sudden you're not getting zone updates, and so your signatures are going to expire. These are some of the concerns that you can come across by having somebody else host your data that you just need to be careful of. And of course, monitoring can help with some of this by looking at all the servers that are authoritative for your zones. But anyway, the way that we calculated this particular metric is simply by taking putting all your servers in a hat and pulling 2 of them out at random with replacement, and calculating the probability that you would get 2 distinct organizations selected from this hat. So the idea was to get a single number basically that kind of represented the distribution, and so that's what this is. And so if we look at I'm not sure how well these, I guess you can see them better on those screens, but if you look at the way this turned out for hierarchical reduction potential so if we look at all zones was about, I think, 8 million zones that we analyzed for this from our data, and we found that there's about 95% of them had a 0 hierarchical reduction potential, which is good. There were about 11 or 12% there that had of the production sign zones that had a non-zero hierarchical reduction potential. And similarly, with administrative complexity, we see a similar type of pattern here. And again, what this represents is the diversity of organizations. And there were a lower number, specifically about 75% of the production sign zones that had a 0 administrative complexity, compared to about close to 90% in the complete set of zones that we analyzed for this. Okay, so with these things in mind, we want to look at and remembering some of the ways that DNSSEC has had challenges in terms of deployment in the different ways of expired signatures, DS resource record mismatch. There are excuse me. There are several ways that this can be avoided, and the first is following the best practice operational standards, which are documented in the RFCs. For example, key rollover procedures, RFC, that's RFC 4641, is going over a revision, but also the trust anchor rollover procedures, and that's in RFC 5011. And then there's also this notion that I alluded to earlier, which I call validation diligence, and that means keep trying till the other authoritative servers, if you get it right. That's another method to try and do this. But then the idea is one of the challenges might be where can you find optimality with that. And also it might be you could have problems where it's actually a symptom of something larger, so it's good to know when you have these inconsistencies. Even if a validator can find its way around it, maybe it's a symptom of something larger that's coming around. Okay, so one other idea that we've come up with to mitigate some of the misconfiguration is an idea called what we call soft anchoring. And the principle behind it is that DNS keys typically don't change too often. Maybe your ZSK rollovers are happening perhaps monthly, KSK rollovers maybe yearly, something like that. But they're not changing too often. And so if we take resolvers and the trust anchors that they typically use, which we refer to as a hard anchor, and then from that hard anchor we derive what we call soft anchors from those, and those are DNS keys further down in the ancestry that are authenticated from existing hard anchors using the chain of trust. And so in the diagram here you can see that the resolver has its trust anchor at the root, but has also learned what we call these soft anchors further down. And the idea behind this is that if for some reason there's a break in the chain, such as this break in between com and bar.com because of a bad KSK rollover, if your resolver has maintained this soft anchor, learned and maintained this, then it can now be it's not going to be inhibited by zone class misconfigurations above where that's anchored, and also delegation class misconfigurations in this particular example. So some of the logistics for this, the idea is that it follows RFC 5011 in a lot of ways, but the difference is that you really have to assume that the zones for which you're maintaining keys are not following RFC 5011, because RFC 5011 was designed for people that are explicitly following trust anchors and watching their rollovers, and most zones don't have that need because they're not the root, and so people don't necessarily need to be anchoring at places below the root. And so in principle, what's happening is the resolver is periodically pulling this soft anchor zone, and then soft anchors are added when it notices that new DNS keys show up in the resource record set and persist for some particular hold down period. Or, excuse me, if the DNS key exists and shows up, and there's also a corresponding DS record that shows up for that, then that's some kind of an indicator that this is a reasonable DNS key to add to as a soft anchor. And then for soft anchor removal, there are three ways at the moment where soft anchors could be removed. That is if the delegation to the zone where the soft anchor exists is made insecure for some reason. So in other words, if the DS records are removed at some point in the ancestry above it, or if the DNS key is revoked, and that's, when I say revoked, I mean in terms of RFC 5011 standards, or if a DNS key corresponds to the DS resource record, and thank you. And both are removed. Now there are some limitations with this particular idea. First of all, if there's a misconfiguration at or below this bottom link in the chain of trust, and that particularly refers to insecure delegations, then it's not going to be of any help in that particular case because you don't have a trust anchor below that. Okay, so you can only help at that level. Also, there has to be some initial notion of trust, meaning that the resolver, if there's some kind of a break in the chain before the resolver goes through this process, then it's not going to help the resolver go through this. So it has to have some initial idea of trust to go through that. And then finally, scalability, and this is more of a technical implementation issue, but how well would this scale? It's hard to tell. You may use some least recently used policy to help out with this. But particularly, we look at this as this something that might be helpful as DNSSEC deployment gains ground, and you have an issue such as a resource record, a signature that expires at the top-level domain, which has happened several times in the last few months, and you have zones signed behind that, and you have people actually validating. You have zones signed below that, and you have people actually validating that. Then you want to be able to you don't want to have 100 calls from your customers saying, why did this go down and what can you do? And so you're forced to turn off DNSSEC validation because of that. Okay, so those are some of the ideas behind this. Okay, so just in summary, DNS responses, we're trying to achieve not only accuracy and truth in our DNS responses, but also availability. Some careful considerations in DNSSEC deployment. And then finally, soft anchoring is one of the techniques that we've introduced to mitigate the effects of misconfiguration. And there are a couple acknowledgments of people that have helped out with this idea, Intel Corporation and UC Davis. Are there any questions?
Kevin Oberman from ESNet. We recently added our DS records to .NET and attempted to add them to .org. Thus far, our registrar, who I'm not going to name right now, but I'm grateful that they're accepting DS records. This isn't a complaint about them. I just don't want any either to go into it at this point because I don't think they're doing anything wrong. Nonetheless, our registrar and the registry for .org can't seem to figure out how to make the DIT transfer. .org says they accept records. Our registrar says we're sending them the record, but they're being rejected. How big of a problem are we going to see between registrars and registries, particularly since the one I'm using as a registrar is one of the largest registries out there, and they still can't seem to quite figure out how to make the system work. And I will say that for this particular registrar, we are a prototype. They're experimenting with us. It is not something they're providing to the public in general.
That's a really good question. And unfortunately, I'm not sure I have the expertise to answer that because I haven't dealt a lot with actually the zone DNSViz.net. I've tried to transfer that. I'm in the process of trying to transfer that to someone because my registrar currently doesn't even accept DNSSEC. I'm not sure they know what it is.
I feared that might be the case. .gov obviously is run by a totally different group of people.
Yes.
I won't say I haven't had some issues with that one, but it's been working for a while at least, and I haven't had any serious problems with it. No other questioners. So I've got one other issue that has kind of disturbed me a little bit. I've talked to several registrars now, all of whom say they do not and do not plan to do RFC 5011 at any time ever. They say that it does not appear to be something that is amenable to their business plan, and it just isn't going to happen. That keys are going to have to be submitted manually, as far as they're concerned, forever. Is there any reasonable resolution for this? It strikes me as just an invitation for breakage if everything always has to be done by hand.
You're talking about in terms of your rollovers?
Yes, when I do KSK rollovers.
I'm not speaking on authority here, but I'm not sure if people have put in place RFC 5011 from the parent zone perspective to look at the changing keys to their child zones or not, and whether that's something they're using or if there are other things in the works to be able to do that securely.
Well, at this point, the only ones I've talked to who have a solution in the works at all have been just you're going to go to a web page and put your new DS record in before your old one expires, and sort of like you have had to do with some of the early prototype systems. But they've all said that as far as they're concerned, that's their final solution. They're not planning on implementing any automated system whatever at any time. I questioned that with them, and it appears that you weren't aware of that situation either. And I don't know if there's a specific technical reason that they seem to be so consistently saying we're not interested in doing that or not. I'm utterly baffled by it, actually.
Yeah, so this actually came up at a meeting I was at the OARC meeting in October, and one of the folks there that addressed this, and I think the perspective was correct, that they were addressing it from a perspective of resolvers using trust anchors. And I think from that perspective, you wouldn't expect any, especially with the signing of the root, you wouldn't expect resolvers to be using trust anchors other than the root, with the exception perhaps of DLV services while they continue to exist, and because you would expect everything to be done at that level.
Absolutely, yes.
Right, and so anything else might be they would consider extra overhead from that perspective. Now, if you're looking at it from a perspective of key rollovers, that might be a different perspective, and someone else might be a better source in terms of what's gone on in the community in terms of standards for that, for automated rollovers. But I personally think that there needs to be something less manual, but what's the word? Accurate when performing these key rollovers between parent and child.
It's clear that the registrar registry issues are going to take a while to iron out, and particularly the case of registrar transfers may take a very, very long to straighten out, but I think that's the issue of why should I do something I'm not being paid for? And I don't see a solution, unfortunately.
Yeah. And by the way, I know you were talking about this from a little bit different perspective, but the idea behind the soft anchoring notion that I presented in here was that not depending on the zones, that it was monitoring to implement RFC 5011.
Hey, Shyam from Mozilla over here. The graphs you showed us, over what period of time was that data collected?
Let's see, this was a long time ago. I believe this was, these particular graphs were started in May. Mm-hmm. No, I think it's June and July of last year.
Okay, and do you plan to continue looking at this over a period of time?
I've been monitoring it since then, and in fact, I just in about a couple weeks ago started a different monitoring system, which was a little bit better. It was keeping actual raw data instead of kind of pseudo data that I was before, and so I actually had some different results to present here for about a 5-month period. Probably would have been longer, except for some technical logistics, but yes, I am recording data for other zones. One limitation I have is I don't have a diversity of, what do I want to say, maybe as a diverse set of data as some other sources do at this point.
Okay, and do you have an adoption rate for DNSSEC by any chance? Like
I don't. I might refer you to SecSpider, and I know some of the folks from SecSpider, Eric Osterwell is here, probably are a better resource for actually looking at DNSSEC adoption rate. So that's one of the ones that's been a little bit more diverse in terms of looking at widespread, who's deploying it. Mine was more looking at most of my data, to be honest, came from resolvers, names that were being resolved in different places. I used those as my basis because I knew they were actually being used, and some other different sources. But yeah, in terms of widespread deployment, I'd probably point you to SecSpider is one, and I can't. Maybe Eric's up here at the mic, so maybe he'll tell you the other one. But I can't remember the site for the other one.
Yeah, Eric Osterwell, Verisign Labs. SecSpider's been tracking deployment growth for 5 years. So it's secspider.cs UCLA.edu, and it has key lifetime distributions and rollover frequencies and stuff like that. So the other one is IKS Jena in Germany, but it's sort of a subset of SecSpider. So.
All right, thanks.
Thanks, Eric. Any other questions or comments?